When you open Google or send a message on WhatsApp, what is actually happening behind your screen? Yesterday, we talked about the OSI model, but that framework is primarily a reference tool. The actual engine running the internet, the practical model used by every connected device right now, is the TCP/IP model. This model achieves global communication using a stack of just 4 specific layers. Understanding how these 4 layers operate is the difference between guessing how the internet works and knowing its mechanical reality. To see how this process works, let's track a single piece of data from the moment you hit send. We start at the top with the application layer. This sits closest to you, the user, where your web browser or email client generates the initial data. Next, the data drops to the transport layer. This acts as the delivery manager, dictating exactly how your data will travel across the network. Here, the system makes a choice: use TCP to ensure reliable delivery through constant error checking, or use UDP to prioritize speed for things like live video. The message then moves to the internet layer. This handles the routing by stamping the data with a destination IP address, so the packet knows its path through the web. Finally, the message reaches the network access layer. This is where your digital information is converted into the physical signals, like electrical pulses or radio waves, needed to travel across hardware. By stepping down through this stack, human-readable text is successfully translated into the signals required to cross the globe. Now, a quick test. Pause the video and try to deduce the exact order the receiving phone will use to process this incoming data. The receiving process happens in reverse order. The destination device takes those physical signals at the bottom, moves upward to strip away the routing and transport stamps, and delivers the raw message to the app. This architecture is why cybersecurity is so specific. Hackers might target the transport layer with a SYN flood to break the connection handshake, or target the application layer with a DNS attack to redirect your traffic. Identifying which layer an attack occurs in allows a defender to isolate the problem. You cannot stop a handshake exploit at the transport layer by simply looking for faults in physical wires. To clear up a common point of confusion, the TCP/IP model is simply a condensed, practical implementation of the 7-layer theoretical OSI stack. This summary shows the 4 layers: application for browsers, transport for TCP or UDP, internet for routing, and network access for physical cables and Wi-Fi. For your homework, write down the specific trade-offs between TCP and UDP, memorize the 4 layers, and compare the OSI model to TCP/IP. Tomorrow, we will focus on exactly how IP addresses function. Understanding this 4-layer stack provides the map needed to troubleshoot real connection failures and secure the protocols that run the modern web.